Hello, greetings to all other esteemed speakers and everyone who has joined today's session. I'm Eeshan and I'm a PhD scholar at IIT Kharagpur, India. On behalf of our joint research team of IIT Kharagpur and University of Leeds, I'd like to thank the organizers for providing us such an exciting opportunity. A pandemic like COVID-19 is a once in a century phenomenon, and it has definitely brought changes in our activity pattern as well as travel behavior, which prompted us to model its effects on motorist behavior in India. I would also like to add that our research work has already been published in the Journal of Transportation Research Interdisciplinary Perspectives. So if you want to more in detail about our work, please feel free to check the journal paper. For today's presentation, I've divided it into four parts. Let's begin with motivation. In the beginning, we need to know why it is different from Global South as compared to the rest of the world. The answer is in the left side of your screen. If you follow the chart, you'll observe that there has been significant spatio-temporal variation of COVID-19 infection. For example, the period of January to March, when COVID-19 was spreading like a wildfire in Europe and Americas, the infection rate was significantly low in Southeast Asian countries. That means that people here in Global South actually got time to know about the deadliness of the virus and need of social distancing. That knowledge has definitely impacted their travel behavior, and such natural behavioral responses are important to model. Other than that, there has also been disparity in the reaction from government. That means how different lockdown norms were imposed and also heterogeneity in public reaction. If we divide COVID timeline into various stages, we can identify broadly four stages spanning from pre-COVID to late COVID where we are in currently. Pre-COVID basically means the normal time period. So we have information, data, transportation model for that, and mid-COVID phases where different administration across the world imposed restrictive measures like full lockdown or semi-lockdown. There has been hardly any public movement, so it's very straightforward to model. The most interesting but gray area is early COVID, when there is no such restriction, but people actually change their travel behavior out of this self-protection concerns. So these differences in time period actually helps us to develop our a priori hypothesis, that is, first one being how this global outbreak of pandemic impacted our activity travel choices. Secondly, how this deviation is different for commute vis-a-vis discretionary trips, and how this choices is going to stay in the post-COVID world. Finally, framing our research question, we frame three. The first one being how COVID-19 impacted trip frequencies and mode choices. Secondly, whether this is different for commute and dispersion trips. And thirdly, what are the implications in terms of transportation demand and planning. As a framework, we identified majorly three categories of influencing factors. Those are first one being social demographics, second one trip attributes, and the last one being contextual attributes. We also did separate analysis for commute trips and dispersion trips to understand if there is any significant differences. And as of choice decisions, we attempted to model simultaneously mode choice and trip frequency and to investigate how this changed from pre-COVID to early COVID period. The second part of our presentation is about data, which is very interesting and also tricky because we collected the data during COVID-19. So we relied mainly on the Google Forms platform as personal interviews was not possible. We collected the data for a period of almost 3 weeks spanning from 24th March to 12th April and collected about 500 individual data points. And we also used both unpaid and paid channels to disseminate our survey questionnaires to maintain better representativeness. Talking about the survey questionnaire, it has three major sections. The first two being collecting information about travel mode and its weekly frequency for pre-COVID and early COVID dates. And the third one being asking people information about personal level and household level social demographic. We did two types of descriptive analysis. The first one being Fritzsche and the second one being inertia, which I'll be discussing later. Based on the characteristic similarity of various modes, we group them into 5 major categories, which have been mentioned just below the figure. And when we tried to observe the trend, how it changed from pre-COVID to early COVID period, and whether this changing pattern is similar or different for commute vis-a-vis discretion trips, we found out some interesting facts. For example, we observed for on-demand private vehicles and shared vehicles, it has gone down, and it has very similar trend for both commute and discretion trips. Whereas we observe for virtual mediums, it has gone up because there you are actually not coming in contact with unknown people, so you have very less risk associated with that. But the trend is slightly different for commute and discretionary. At the same time, we observe reverse trends for NMTs and private vehicles when we compare the commute and discretion trip. The second type of descriptive analysis that we did is related to inertia. So let's define the term inertia first. Say, if I'm using car in pre-COVID time, I'm likely to have an additional propensity or stickiness to continue using car in early COVID time too. This has been termed as inertia. And we observe the trend for commute trips here in this chart. The switching propensity for work from home and personal vehicles are comparatively higher than other lower social distancing mode like shared vehicles, NMTs, and ODPVs, which is because they get higher social distancing and you come in contact of less people when you're covering in your own vehicle. So there has been less risk associated with that. Similarly, another interesting observation is that we can find lower inertia for ODPVs as compared to shared vehicles and NMT, which might be attributed to the fact that those are more expensive and has spatial restrictive coverage. Similarly, for discretion trips, we find higher inertia for private vehicles and online, but in an interesting difference to commute trips, inertia for NMT is greater than online mediums and personal vehicles. The reason might be people wanted to procure the essential items quickly during that period, and also in some areas these online activities were restricted, which resulted in high delivery period. So people trusted more on going to the local shops or going afoot to collect these items from their neighborhood. Coming to the third section, we'll discuss about the model. So let's begin with discussing the methodology. As it discussed in the framework, that we attempted to jointly model the mode choice and the trip frequencies, where we consider the mode choice as the discrete one and the trip frequency as the continuous choice. For that reason, we opted to use MDCAV model, that means multiple discrete continuous extreme value model, over other statistical model. And here we consider the saturation parameters alpha and gamma to be fixed at 1. Now I'll be discussing the results separately for commute trips and discretion trips. Let's begin with the commute trip results. So I'll be mainly highlighting the key findings of this estimation results. What we observe that for higher social distancing modes like car, motorbike, which are like personal vehicles, you have higher inertia, which is quite expected because here you can travel by your own or with known person like your family members, so a very less risk of contracting COVID. But interestingly, this inertia also varies with trip distances. For car, we find higher inertia for long trip distances, whereas reverse happens for motorbike, which might be associated with the fact that in case of motorbikes for long distance trips, you are getting longer exposure to the COVID environment. So your fear of getting infected with COVID. For lower social distancing modes like shared vehicles and NMTs, we observe lower inertia, But for shared vehicles like suburban trail, which has mostly captive users, we observe slightly higher inertia as relative to NMT. Other than that, we observe that these choices is also influenced by the socio-demographic variables like gender, monthly household income, age, and occupation. For example, this high income people has greater affinity to car and ride hailing during normal period or pre-COVID period, but their affinity decreases as they shift more towards working from home. Similarly, the young millennial group has greater affinity for bus or public transport, but that decreases during the early COVID days. Coming to the discretion trip results, we observed similarly that higher social distancing mode has higher inertia, but in a different way that for car and motorbike, for long distance trips, there's higher inertia. If you remember that for commute trip we observed for motorbike, it was high inertia for short distance trips. Here, the reason might be in case of discretion trips, you want to join various trips in your single tour, like going to a laundry, then collecting some from grocery, doing some other activities. So that works better for us. So that might be the reason that inertia for long distance is higher for both car and motorbike. The other thing that's for low social distancing, we observe intuitively lower inertia, but another interesting difference is for NMTs, we can observe higher inertia as compared to other low social distancing mode. The reason might be same that we explained for inertia chart, that people were going to the local neighborhood shop instead of traveling to a distant location by motorized modes. Similarly, for discretion trips, we observe different socio-demographic variables like monthly household income, age, vehicle ownership strongly influences the choices. Interesting point you can observe for vehicle ownership is that people or households which has car and motorbike, they are very important factors which contributes to their choices, but still their affinity towards NMT increases in early COVID days as compared to pre-COVID. And the last part, the policy implications. We have generally threefold policy implications for transport planners, transport network companies, and transit operators. The key takeaway points is that you need to be cautious about increase of single occupancy private vehicles. So we need to encourage the active use of NNTs, specifically for transit operators. They need to upgrade their service both in terms of hygiene and operational quality, and need to integrate various smart measures. In case of transport network companies, they can try to be more smarter by encouraging shared use only with known co-passengers and also installing various protective arrangements. And at the end, they can also integrate online food deliveries and other distribution activities too to develop their modus operandi. Currently, we're looking at the incorporating the effect of context and other regional variation, at the same time quantifying energy and emission impacts. At the end, I'd like to point out that we predicted in our model that has been made for the period of March to July that single occupancy private vehicles and NMT trips are going to increase respectively for commute trips and discretion trips. So what we observed from the Apple and Google mobility reports is that that actually happened, which supports our prediction that both driving and walking, you can find from Apple mobility reports, has increased for this period, August to December. Whereas Google mobility report shows that the grocery and pharmacy stores check-in is more than the normal period. That means what we predicted, that people are going out to the neighborhood or local shops instead of going online, that has actually happened. Whereas people prefer working from home, that's why you can find that workplaces are still below the normal level. That's all from my end. Please feel free to ask any questions. Thank you.